We are trapped on a fragile blue marble, suspended in a cosmic shooting gallery, and we have convinced ourselves we are explorers destined for the stars. But the universe has built walls around us, walls made of radiation and velocity and the cold mathematics of biology, and every attempt to leave this gravity, well, every rocket we fire, every mission we plan crashes against an invisible blacklist of problems that have no solutions, not with our current physics, not with our current bodies, not even with our current minds. And the list is terrifying: the biological fortress that kills us at the cellular level, the propulsion dead end that makes interstellar travel a generational suicide pact, the navigation trap that leaves us blind in the cosmic ocean, and the psychological void that shatters the human psyche in the silence between worlds. The human body is an exquisite machine calibrated across 4 billion years of evolution for one very specific environment. The surface of Earth at one atmosphere of pressure under one gravitational constant, with a magnetic field deflecting solar wind and an ozone layer filtering ultraviolet death. Remove any one of these variables, and the machine begins to fail. Remove all of them simultaneously as space travel demands, and the failure becomes catastrophic at the molecular level. Begin with gravity. Every cell in your body, every muscle fiber, every bone lattice, every cardiovascular valve was sculpted by the relentless downward pull of Earth's mass. In microgravity, the body interprets weightlessness as a mistake and begins to cannibalize itself. Osteoclasts, the cells that break down bone tissue, accelerate their activity, while osteoblasts, the builders, go dormant. Astronauts on the International Space Station lose between 1 and 2% of their bone density per month. A Mars mission lasting 18 months would see crew members arrive with skeletal structures resembling elderly osteoporosis patients unable to walk under Martian gravity, let alone return to Earth's full pull. We have tried countermeasures: resistance exercise, calcium supplements, bisphosphonate drugs. None stop the decay. They merely slow it. The cardiovascular system fares no better. Without gravity pulling blood toward the legs, the heart adjusts to pump less forcefully. Muscle atrophy sets in, cardiac walls thin, and when astronauts return to gravity, they experience orthostatic intolerance, fainting, dizziness, and inability to stand without blacking out. The fluid shift is immediate in microgravity. Blood and cerebrospinal fluid migrate to the upper body, causing facial puffiness, sinus pressure, and a condition called spaceflight. Associated neuroocular syndrome, where the optic nerve swells and flattens the eyeball, causing permanent vision degradation. Some astronauts return from 6-month missions with irreversible hyperopic shifts, their eyesight permanently damaged. Then there is radiation, the invisible killer. Earth's magnetosphere is a protective cocoon deflecting the solar wind, a stream of charged particles that would strip our atmosphere and sterilize the surface. Beyond low Earth orbit, beyond the Van Allen belts, astronauts are exposed to galactic cosmic rays, high-energy protons and heavy ions traveling at relativistic speeds, originating from supernovae outside our solar system. These particles tear through spacecraft hulls, through water shielding, through human tissue, and when they strike DNA, they shred it. Double-strand breaks, chromosomal aberrations. A Mars mission would expose crew to radiation doses exceeding 0.6 sieverts, enough to increase lifetime cancer risk by 5 to 10%. A journey to the outer solar system or beyond would be a death sentence, not from immediate radiation sickness, but from a statistical certainty of malignancy within years of return. We cannot shield against cosmic rays. Lead is too heavy. Water helps, but you would need meters of it, adding impossible mass. Electromagnetic shields remain theoretical, requiring power generation we cannot yet miniaturize. The human body in deep space is a tumor waiting to metastasize, and we have no solution. The romantic vision of interstellar travel, the sleek starship accelerating to a fraction of light speed, is a fantasy built on a misunderstanding of the rocket equation. Tsiolkovsky's tyrannical formula delta V equals exhaust velocity times the natural log of initial mass over final mass reveals a brutal truth. To go faster, you need more fuel, but more fuel adds mass, which requires even more fuel in an exponential spiral that devours itself. Chemical rockets, the only propulsion system we have successfully deployed, are pathetically inefficient. The space shuttle's main engines achieved an exhaust velocity of 4.5 kilometers per second. To reach Mars in a reasonable time frame requires a delta V of approximately 6 kilometers per second. To reach the edge of the solar system, multiply that by factors of 10. To reach even the nearest star, Proxima Centauri, 4.2 light years away, you would need velocities approaching 10% the speed of light. Chemical propulsion cannot deliver this, not even close. Ion drives are better, exhaust velocities of 30 to 50 kilometers per second, using electric fields to accelerate ionized xenon, but the thrust is minuscule. NASA's Dawn spacecraft took years to reach the asteroid belt. Scaling ion propulsion to human-carrying vessels requires power sources we do not have. Solar panels are useless beyond Jupiter, and nuclear reactors massive enough to generate the necessary megawatts add prohibitive mass. Nuclear Pulse Propulsion Project, Orion's concept of detonating atomic bombs behind a spacecraft and riding the shockwave, could theoretically achieve 5% light speed, but the engineering challenges are staggering. The vibration would pulverize instruments, the radiation would cook the crew, and the political reality of launching thousands of nuclear warheads into space is a non-starter. Antimatter, the holy grail of propulsion, offers perfect mass-to-energy conversion, but we produce antimatter one atom at a time at costs exceeding trillions of dollars per gram, and storing it without annihilation requires magnetic bottles that consume more energy than the antimatter provides. And even if we solve propulsion, even if we achieve 10% light speed, the journey to Proxima Centauri would take 42 years. The travelers would age, the ship would degrade, systems would fail, radiation would accumulate. Multi-generational ships are proposed, but they require closed-loop ecosystems. We cannot yet build rotating habitats to simulate gravity that introduce mechanical complexity we cannot maintain, and social structures that must remain stable for centuries without resupply or contact with Earth. We are cosmically landlocked. Navigating Earth's orbit is trivial. GPS satellites, ground-based radar, the visible landmarks of continents and cities. Navigating interplanetary space is manageable. We use radio signals, tracking the Doppler shift and the time delay to calculate position relative to Earth and the Sun. But navigating deep space beyond the heliosphere, the bubble of solar wind that marks the Sun's domain, is a descent into existential blindness. Stars, the ancient navigational tools, are useless at interstellar distances. They do not move relative to a human timescale, but a spacecraft traveling at relativistic speeds experiences apparent stellar motion and relativistic aberration. Stars ahead blue shift and crowd forward, stars behind red shift and dim. The constellations we use to orient ourselves dissolve into unrecognizable patterns. Pulsars, rapidly spinning neutron stars emitting regular radio pulses, have been proposed as cosmic lighthouses, their rotational period stable to nanoseconds, allowing triangulation. NASA's Deep Space Atomic Clock and the pulsar-based navigation systems are elegant in theory, but require massive antenna arrays to detect the faint signals and sophisticated onboard processing to filter noise. A single hardware failure, a degraded antenna, a corrupted database, and the ship is lost. Worse, the farther you travel, the longer communication takes. At light speed, a signal from Proxima Centauri takes 4.2 years to reach Earth. A distress call, a navigation error, a course correction request, and a reply arrives nearly a decade later. The crew is on their own, navigating by instruments that cannot be replaced, making decisions with no ground control, no mission support, no rescue. And space is not empty. The Oort cloud, a shell of icy debris surrounding the solar system, extends nearly 2 light-years from the Sun, a minefield of comets and planetesimals we have never mapped. A collision at 10% light speed with an object the size of a baseball would vaporize the spacecraft. We cannot see these objects in time to avoid them. We are flying blind through a cosmic shooting gallery. The human mind evolved in tribes on savannas with horizons and weather and the diurnal rhythm of sunrise and sunset. Isolation is torture. Extended isolation is psychosis. And the isolation of deep space is absolute. The ISS orbits 400 kilometers above Earth. Astronauts can see their home, a brilliant blue marble outside the window. They receive emails, talk to family, watch live news. They are isolated but connected. On a Mars mission, Earth becomes a star. Communication delays stretch to 20 minutes. Conversations become asynchronous exchanges of recorded messages, the psychological tether phrase. Beyond the solar system, Earth disappears entirely. The pale blue dot vanishes into the stellar background. The travelers are severed from every human who has ever lived, confined to a metal cylinder hurtling through an infinite void. The monotony is maddening, the same corridors, the same faces, the same recycled air for years, decades, generations. Studies of Antarctic winter over cruise, submarine deployments, and ISS missions reveal predictable patterns. Interpersonal conflict, depression, anxiety, the third quarter phenomenon, where morale collapses midway through isolation. Crew members develop irrational hostilities, withdraw into catatonia, or experience dissociative episodes. Medication helps until it runs out. Therapy requires a therapist, and the only trained personnel are on the ship, trapped in the same nightmare. Sleep becomes disordered without natural light cycles. Circadian rhythms collapse. Insomnia, chronic fatigue, hallucinations. The lack of privacy, the constant surveillance, the knowledge that escape is impossible, that turning back is not an option, creates a pressure cooker environment. Mutinies are not historical curiosities, they're statistical inevitabilities. And if something goes wrong, a medical emergency, a fire, a hull breach, there is no rescue. The crew must solve the crisis themselves or die. The psychological burden of that responsibility, the knowledge that every decision is life or death, wears the mind down into despair. NASA's Artemis program aims to return humans to the moon. The Mars missions are planned for the 2030s. These are magnificent achievements, testaments to human ambition and engineering. But they are not escape. They are expeditions to neighboring rooms in a cosmic prison. The Blacklist is real and unforgiving. Biology, radiation, and microgravity will kill us. Propulsion is constrained by physics we cannot yet break. Navigation becomes guesswork in the deep. Psychology fractures under isolation. And beyond all this is time, the cruel erosion of mechanical systems, the degradation of electronics, the mutation of DNA. We are quarantined not by law, but by the universe itself. The distances are too vast, the speeds too slow, the human body too fragile. Until we transcend our biology, engineer new physics, or accept multi-generational extinction events as the price of exploration, we remain bound to this blue marble adrift in the dark. The stars are visible but unreachable, and the blacklist grows longer with every mission we attempt.